A sewage works such as this treats nearly 40,000 cubic metres of mainly domestic sewage each day. At this site, trade waste from 2 local food manufacturers comprises about 8% of the total flow. Rainwater runoff, referred to as surface flow, is also treated. For simplicity, we'll refer to all the incoming wastewaters as sewage. The pollution load in the sewage equates to a population of 220,000. A large works like this requires only 4 people to operate it, thanks to telemetry, which monitors equipment and alerts technicians whenever any malfunctions occur. The raw sewage entering the works passes through 6mm mesh screens. The collected solid matter is called screenings, and typically comprises rags, cotton buds, sanitary products and paper. The screenings are compacted and sent to landfill. The sewage then flows to a grit extractor of the cross-flow type. Where road grit and other inorganic matter settle out. This material is subsequently washed and also sent to landfill. On leaving the grit extractor, the sewage enters the primary settlement tanks. Here, approximately 70% of the remaining solid matter settles out and forms primary sludge, which collects in a sump at the bottom of the tank. Periodically, the sludge is pumped away for disposal or for treatment. Above the sludge lies the wastewater. It now has a greatly reduced amount of suspended solids, and with it about 30% less biochemical oxygen demand, or BOD for short. On this site, the wastewater is treated in one of 3 different types of biological system, namely biological filters, activated sludge units, or oxygen ditches. When the site first opened, there were only the biological filters, but as the site grew and evolved over the years, the activated sludge units and oxygen ditches were installed. Here you can see the rectangular biological filters. In many works they're circular. But irrespective of their shape, biological filters are robust and easy to operate. Microorganisms growing on the clinker in the bed break down the organic matter in the effluent. On leaving the filters, the effluent is dosed with ferric sulfate in order to precipitate out the phosphates. This prevents eutrophication occurring in the river when the treated effluent is finally discharged at the end of the process. The effluent then goes to a humus tank for secondary settlement, where microbial solids and precipitated phosphates settle out and are removed as sludge. You can see that the water looks much cleaner than it was at the inlet. To improve the water quality further, the effluent is filtered through gravel filters, sometimes referred to as deep sand filters. Once these filters are full of solids, they're backwashed, and the washings go to the inlet of the works. The treated effluent is now suitable for discharge to a river. An alternative to the biological filter is the activated sludge unit. Here the wastewater is aerated and mixed by fine bubbles of air blown through hundreds of ceramic or plastic diffusers such as this. The organic matter in the sewage is again broken down by microorganisms, but this time they're suspended in the mixed liquor in the tank. The remaining system is the oxygen ditch, where almost 1/5 of the sewage at this plant is treated. Interestingly, the oxygen ditch doesn't require primary settlement. The sewage is aerated with the help of large brush aerators, and the effluent moves around the ditch, allowing the organic matter to be degraded by microbes in suspension. On exiting, it goes to a settlement tank and then to the gravel filter. Treated effluent from all 3 systems comes together before discharge into the nearby river. The sludge from the primary and secondary settling tanks is thickened in a picket fence thickener, then centrifuged And finally, lime is added to stabilise it. Sewage sludge can be anaerobically digested to produce a combustible gas, buried in landfill sites, composted, or incinerated. But most of it's transported to farms for use as a soil conditioner. Water quality is constantly measured using remote automatic sensors and double-checked periodically by technicians. The final output from this works is well inside the statutory requirements. The works can fully treat 3 times dry weather flow. If the incoming flow is greater, then after passing through the grit extractor, the excess cascades over this weir into the channel on the left and flows into storm tanks. Here, just under 14,500 cubic metres of sewage can be stored and treated later. This is the equivalent to 3 times dry weather flow for 2 hours. In the unlikely event that the flow to the works is greater than 6 times the dry weather flow, the storm tanks are designed to overflow and discharge direct to the river. Only in exceptionally heavy rainfall would this occur, typically about 12 to 15 times a year. This isn't as bad as it sounds. Firstly, the effluent is highly diluted with rain. And secondly, the river will be in spate, and hence further dilution of the effluent takes place, thus minimising its impact on the environment. And finally, any discharge direct into the river has the associated and necessary legal consent issued by the national regulator.